So yesterday I told you that you would recognize that arithmetic sequences were linear. So today we're going to recognize this. So here is a list of numbers, 1, 5, 9. Just like yesterday, you should be able to decide, is this arithmetic or not? Do they have a common difference? So again, you check. 1 to 5 is 4 with addition. 5 to 9 is also adding 4. So our common difference is 4. From yesterday, you should be able to write out the equation for this. A sub n equals a sub 1 plus n minus 1 times d. And again, you leave a sub n alone. You fill in your first number, leave the n minus 1 alone, fill in your common difference. We're going to simplify. So we're going to distribute properly. And we get that a sub n equals 4n minus 3. And again, this should look familiar. 4n minus 3 kind of looks like 4x minus 3, which is an equation that we were using a couple of days ago. But anyway, we have our equation. Let's look at what happens if we graph these numbers. So our first number is 1. Our first number is 1. Our second number is 5. Our third number is 9. Doesn't that look linear? And instead of having x's on the bottom, we have n's. And instead of having y's going up the side, we have our terms. So again, it looks like it should be a line. Arithmetic sequences are linear. So from yesterday, you should be able to use your new equation to find, say, the 12th term. And when you're done with that, you should be able to figure out which term the number 172 is. Please do both of these things. So to find the 12th term, you just plug in 12. 4 times 12 minus 3 should give you a nice even 100. For the second part I asked you to do, 172 equals 4n minus 3. To solve for n, you want to get rid of the 3, so you add. Well, 175 can't equal 4n, so 175 is not on our list. It is not a term in the sequence. Let's look at this example for a moment. You could, hopefully, pick these points off of the graph and stick them on that table. Please take a moment to do so. It would probably help if everything lined up nicely. So we have 1, -2, 2, 0, 3, 2, and 4, 4. So looking at this, if you remember from what we just did, instead of x's, we can think n. Which term are we? Instead of y's, we can think a sub n, the number in the list. So our list is -2, 0, 2, 4, and it could go on forever. Therefore, we could write an equation for this list. To get from -2 to 0, you're adding 2. That is consistent every time, so we have a common difference. And again, using a sub n equals a sub 1 plus n minus 1 times d. Please fill in the appropriate things and get an equation. You always leave a sub n as a sub n. Fill in your first term. N minus 1 stays n minus 1, and in this case, d is 2. Distribute properly, and we get that a sub n equals 2n minus 4. And we could, of course, use that equation to find some other numbers in the list if we needed to. If you were to turn to page 192 and find problem 4, this table would be there. And I would like us to write an equation for this list. So first of all, the numbers on top are the x values. And the number on the bottom are the y values. And we're using n for the top, so that's just the location in the list, and y is our numbers. So we have 8, then 9.5, then 11, then 12.5. So your first job, as always, is to decide, is this arithmetic? Does it have a common difference? So hopefully you notice that you are adding 1.5. And since you're adding 1.5, you should be able to write an equation. And again, you're using a sub n equals a sub 1 plus n minus 1 times d. So you leave a sub n alone. A sub 1 is 8, and d is 1.5. Distribute properly. A sub n equals 8 plus 1.5n minus 1.5. A sub n equals 1.5n plus 6.5.